Hello everyone. Today we're going to look at Intro to Variable Terms and Expressions and combining like terms. Any non-number symbol can be used to represent an unknown quantity, which is typically called a variable. They're usually written or represented by letters, except just remember that E, I, and the Greek letter pi already have numerical values associated with them, and so they're not actually variables. Every variable term has a variable and a coefficient. So we're going to look at a couple examples. We have the variable term 5x. The variable is the x. The coefficient is the 5. So remember, the variable is the letter or the symbol representing the unknown quantity. The coefficient is just the number that is being multiplied by the variable. 32xy squared. We have more than one variable. We have x and we have y. The variable isn't y squared. The variable is y. The coefficient is 32. We have 1/4 z to the 4th. The variable is z. The coefficient is 1/4. 2 theta over 3. That's the Greek letter theta. The variable is the theta. The coefficient is the 2/3. So don't forget that 2 theta divided by 3 is the same thing as 2/3 theta. Alpha squared divided by 4. The variable is, again, the Greek letter alpha. The coefficient is 1/4. Remember, when you divide by a number, it's the same as multiplying by the reciprocal. So alpha squared divided by 4 is the same thing as alpha squared times 1/4. So the coefficient is 1/4. And then the last one, y. The variable is y. The coefficient is 1. Remember, if there's nothing in front of the y, it's a 1. So the coefficient is a 1. An expression combines variable terms and or constants with a plus or a minus. So for example, 4x plus 2, 3x squared y minus x cubed plus over 2 plus 0.73934, 5 minus 3x, 23, y. All of those are expressions. Versus an equation. An equation is when you have two expressions equal to each other. So an equation must have an equal sign. Something as simple as x equals 4, or something more complicated. 36 squared plus 8 equals 4x minus 0.456y cubed. Or an equation you might see later on, c equals 2 pi r. So now we're going to look at combining like terms. 3 apples plus 5 apples equals 8 apples. So remember, terms are things that are separated by plus or minus. So I have 3 apples plus 5 apples. That gives me 8 apples. If I had 3 apples plus 5 cars, that is equal to 3 apples plus 5 cars. I cannot combine them. The most I'd be able to do in English is say that it's 8 things, but that's not what I can do mathematically. I cannot combine them. They're not the same thing. I've got apples and I've got cars. So like I said, we cannot simplify it. We need like terms in order to combine them when we're using addition and subtraction. When it comes to multiplication and division, it's quite different. So when we say combine like terms, we mean using addition and subtraction. And two terms are alike if they have the same variables raised to the same powers. So they both have to have an x squared and a y cubed and no other variables, for instance. So we're going to do some examples. 3x plus 2x plus 5x squared. So if we notice, all three of our terms have the same variable, x, but our third term has it raised to the 2, where the first two terms have it raised to the 1. So these two are like terms. They both have an x raised to the 1, and I can combine them. 3 plus 2 is 5. So I have 5x plus 5x squared. That term that they have in common, that x, is what the new variable is when I add them. So 3x plus 2x is 5x. I have a lot of people who want to tell me that it's 5x squared. But just remember, an apple plus an apple is 2 apples, not apples squared. So the part that they have in common stays there, just like a common denominator when you're adding fractions. B, 5 smiley face plus 3 smiley face minus 4 frowny face. Our variables do not have to be letters. They can be any non-number symbol that you want. So we look at our 3 symbols here and we say, are any of them the same? And hopefully we noticed we have 2 smiley faces and then a frowny face. So the 2 smiley faces I can add together. 5 plus 3 is 8. So I get 8 happy face minus 4 frown face. 6ab squared plus 8a squared b minus 3ab. So again, notice all 3 terms have the same variables. They all have an a, they all have a b, but they're being raised to different powers. In the first term, I have a to the 1, b to the 2. The second term, I have a to the 2, b to the 1. And the third term, I have a to the 1, b to the 1. None of them match up. So I can't simplify it any further. It is what it is. For D, I have 0.7a squared b minus 0.3b squared a plus 0.25ab squared plus 0.38ba squared. So again, they all have an a, they all have a b, but now we have to make sure that the exponents also match. So here in my first term, I have a to the 2, b to the 1. Over here, I have a to the 2, b to the 1. It doesn't matter that they're in different orders. Remember, multiplication's commutative and associative. I can multiply in any order that I want. A squared times b is equal to b times a squared. You just have to be careful and make sure that it's the a that's being squared and the b that's being raised to the 1. So those 2 terms are like terms and I can combine them. The other 2 terms both have b squared a to the 1, b squared a to the 1. Again, the order is not the same, but with multiplication that does not matter. So I can combine the middle 2 terms also. And when I do that, I get 1.08 a squared b minus 0.05 ab squared. Typically, when we have a term with more than one variable, we like to write them in alphabetical order. But I could have just as easily called this ba squared over here, and then minus 0.05 b squared a if I wanted to. Those are both perfectly acceptable. But again, just in general, we tend to write them in alphabetical order. So read the book, try out the homework problems, and let me know if you have any questions. Good luck.